Hi, my name is Vahan Davudyan. I'm a physics experimentalist for 37 years, and this is our topic today, the black body radiation or quantum revolution or quantum mechanics. And this is the logo I created. When you click on this, you can see all my 81 theories, and it says, unique physics concepts by Vahan Davudyan, how to promote the science. And this is my email, vahandavudyan1948@gmail.com. And this is extremely important concept in physics because it started in early 20th century and it solved so many problems for quantum mechanics. And when we're talking about planetary level, it's so different. But when we're talking about atomic and subatomic level is entirely different because it's so weird atomic even nowadays they debate how the quantum mechanic works. There's so many problems, it's not been solved yet, but Max Planck, one of the greatest scientists in the history of mankind, he was a German scientist, he won the Nobel Prize, then he solved this problem. But the bottom line or the overall is, even in a sub-zero temperature, in a winter when you have, black or, dark clothing, you feel much better because, the light, some sunshine from the, light from the sunshine is absorbed. But at the same day, if you have like white or, light clothing, you don't feel that warm because everything is reflected. So the thing is how black something is. The more black it is, the more it absorbs. And this is the definition, is the thermal light given off by an ideal object that absorbs all the light hitting it. Well, of course, this is going to be so important, this theory, so comprehensive, because I have two experiments you will never find in any books, because this is my imagination, and I think this will solve so many problems in quantum physics, especially the behavior of the light. And you can see on this picture, we have red light, we have blue light, and we have UV. And then you can see the red light is hitting the surface, but no electrons is ejected because of the low energy. But the blue light has more energy, but you can see some electrons are ejected. And UV has much more. You can see there's so many electrons are ejected. So it depends on what, kind of surface you are dealing with. I put another poster so you can see what I mean. This is extremely important concept in physics, and this is my imagination. And in fact, I had to buy this. This is precise, I would say 99%. It's called, infrared camera. You don't even have to touch, you can feel everything. Let me show you now. So you can see it's showing 87 degrees here now, see? Because it's infrared. And this was my imagination. Imagine I had black cloth, and then I had gray, blue, and then green, and orange, and red, and the white, and the temperature is 86 degrees, or they call it room temperature, and this is the mirror. So when I did this experiment, so it confirms that, it depends on what color you're dealing with. Like this black is not 100% black because I could find better cloth, but this is not 100% black, but it's showing that exactly 125 Fahrenheit. Well, of course, I'm not going to show you now because it's not sunshine now. So the sunshine, it was 125 degrees Fahrenheit. At the same time, when I did with the white, it was showing 98 Fahrenheit. And then when I did with gray, it was 120 because it's a little bit more dark. And then 116 with the blue and 115 with the green, and the red was 110. But when I did with the mirror, it depends on the angle. Almost 100% of the light hitting the mirror was reflected. I have to explain my logical analysis. Why did I use this infrared? Because when I was so young, I worked with doctors, and then I imagined that they had to put a strip on a baby's face, and then put it their arm or something like that, the tongue. But this is so precise because my imagination, my inspiration came from the human's body. The human ear canal, if you think about that, inside is totally dark. It's a black body radiation. The light goes in my ear, but it doesn't come out because it's reflected back and forth in the canal, and then it's getting absorbed. And this was my idea. And I'm hoping that you guys will love it because this concept is so good. It's new concept, and no one has compared the human ear with black body radiation. Anyway, this is the way I did, and then on top of that, I had to compare with the black hole. But if you think about that, they're two different concepts. When we're talking about black hole, it's extremely, huge magnetic field that, everything can get in, but it won't come out. Especially light cannot escape. So is the black body radiation. And my concept was right because, the light, the behavior of the light has so many things in common. In black hole, which is magnetic, and the cavity radiation, which is not magnetic. So anyway, this was my idea, and you can see there's a hole over here, and I show you this box. Inside is white. So whatever light, it doesn't matter, this artificial light or the sunlight hits it, reflects, would say 100%. But when we close this, you can see inside is dark. But the logical explanation is when the light rays, I'm talking about probably trillions of photons are coming in, they are bouncing back and forth inside the walls, and everything is getting absorbed. It's not coming out. This is called black body radiation, and this is extremely important concept or experiment. You can see why the light, why it's called black body cavity radiation, because this is a cavity practically. I show you the rainbow. This is the rainbow, and thanks to Christian Huygens, who discovered each one has a different wavelength. And you can see like red, orange, yellow, green, blue, indigo, and violet, and violet. But you know what? This picture has been exaggerated a little bit because the boundaries is not clear like that. When you see the rainbow after the rain, this boundaries are a little bit, blended in, but overall you can see this consists of 7 layers. And I remember when I was so young, and we had some Pakistani friends. I was maybe 6 years old. I had no idea what that concept was. 6 years old, and then I was asking him because, they were so good in English. And then I was asking him, why do you guys have completely white? Said because the light is, sunshine is reflected, it keep us cool. Then when I says, that when I touched them, I realized they are right. Then I had to go to my brother and then our science teacher, and they explained, but we were so young, we would not understand what the nature of the light is, but Pakistani and Indian people used to do that. But nowadays, I don't even saw anyone wears like, completely white. But sometimes I can see some Mexicans, they have like, white, huge, hat, so it's a reflecting light, and then they are so protected. And in fact, I have another one which is important also. This is called the scanning tunneling microscope, and this is the direct consequences of the quantum mechanics. And I remember before this was invented in 1986, and there were two Swiss scientists. His name was Heinrich Royer and Gerd Benning in 1986, and both of them got Nobel Prize for this. And the magnification is 100 million times more. I mean, it's beyond your imagination how big it can go. Well, of course, this is not the actual picture. It's just a block diagram, but you can see this sharp point. And guess what? It is so close to the object you wanna, or your probe you wanna check. It's nanometer. 1 nanometer is 1 billionth of a meter. And the precision on this is 0.1 millimeter. It means that smaller than billionth of meter. That's how good it is. So when you enlarge this 10 billion times, you can see unbelievable how good it is. And this solves so many problems. Because before this, we knew existence of atom and neutron and protons and electrons, but they solved everything. And imagine this picture is 7 nanometer by 7 nanometer. It's a cesium atom, and you can see in a row it shows. And this solves so many problems because this quantum mechanics is so amazing. And this one, a scanning tunneling microscope, and the other one is electron microscope, solve the problem. In classical physics, we don't have tunneling, but in quantum mechanics, these two scientists, discovered that, electrons can tunnel sometime, can, take the shortcut they can get, and that's exactly what happened. So this electron, a scanning tunneling microscope solves so many problems in physics. And this is the way it is, and then this is the wavelength, and you can see the one for the, let me tell you which one. See, this is the, graph for the, quantum mechanics, and you can see this is much more stronger. So the main concept is how much light is absorbed, how much light is reflected, and that changes our perception. Think about that. If the moon was, like a red planet, we could not see even the red planet at night, but the moon has the white, sand or white powder or, whatever that is, it doesn't matter. Even at night, sometimes it's clear night, you can see moon is so bright, it looks like the moon is shining. No, practically it is the reflection of the sunlight because white reflects. Well, of course, it's not 100% a reflection from the sun, but sometime I remember many years ago I saw the moon, even the rainbow around the moon, and that was amazing. I was so thrilled, and then I took some pictures, and then I had to go to some physicists and ask. They said that is so rare that sometime happened. So I hope you guys love this. This was in English they call it a concise, coherent and logical explanation. The thing was short, and I'm glad if you like this concept, you can go ahead and subscribe. And then I always like your ideas, your input, and I always honor your input. And no matter what, I'm not that busy. I'm a retired person, and I can respond your email, but your encouragement makes me so good, and then every time I can improve my theories, and then I can be more precise. And thanks a lot for watching. I appreciate your help. Thank you.